I sort of, in a way, started by explaining a little bit about what 3D printing is. And in a school situation, this is where we start with a simple CAD drawing, computer-aided design drawing. For an example at the left, it's then output through a machine, in this case a machine that's called a rapman, and I'll tell you a little bit more about that. And we finally end up with 3D solid plastic products. Now, I've mentioned about the rapman. This is a little bit of a special machine. It's made very locally. It's made in Clevedon. It's made by two guys. One of them is a parent of a student at this school, and one of them is an ex-teacher at this school. They took on the design of rapman from a project at Bath University, which is called the RepRap project. It was to design a machine that would make itself, basically. And that's what these two guys are. And actually, the second generation of this machine, which, yes, I haven't put a picture there, but the second generation of this machine, again made at Bath University, has been reproduced all over the world. It's sort of spawning and sort of being remade and things. The guy who designed that one as his postgraduate project, if you like, is now working for this company called Bits from Bytes. So it rumbles on, it keeps going. To go through the sort of design to make process, and if I lead you through that, and then we start looking at what it actually means to students, I'll try, hopefully, then not to confuse you too much. But if we're talking about software, this software has to be 3D design software. Some of you might be familiar with 3D being sort of meaning an object in your hand. We're here talking about sort of like virtual 3D, if you like. The 3D of an object that is within the computer. There is software that is available to schools free, and so the big commercial one's free through Systems to School, and these are free including open source. Now, I must add a little bit, I don't know what people know about open source. Everybody thinks of software. These are open source, or some of them are open source software packages, but this machine here, the original one, is open source. You can actually download all the designs and make it for yourself without even buying a kit. So, the 3D design, the object, if you like, the virtual object, is post-processed, and it's converted into something called G-codes. Sorry if I'm getting a little bit geeky, but these G-codes, what they actually do is they drive the little motors and things that are involved in the machines. They move around the machine to actually produce the object. And in terms of students in school, it's 6 clicks of the mouse after they've designed their object. This is a clever bit, really. No, I haven't got one in my pocket, which is really unusual. It's in the pocket over there. But this machine runs from an SD card. It doesn't tie up a computer in school. Its SD cards are cheap enough for students to have their own, to transfer their designs. You literally whiz over, pop it into the front of the machine, press print, and it will produce a 3D object according to your design. The actual design is made up of several different polymers, plastics if you like. The two normal ones that they use most often are ABS, same as your car bumper. Very, very strong material. If I put one of the objects on the floor, jump up and down it, I'll probably twist my ankle, but it would survive it. The other material, which is a little bit more sort of user-friendly in some ways, is a material called polylactic acid, shortened to PLA because it's a bit of a mouthful. Polylactic acid is made from cornstarch, it's biodegradable, and obviously not an oil-based plastic, and these machines will use that. Used in combination, these two materials offer some exciting opportunities with producing what's called support material, so you can print overhanging objects and that sort of thing. Now, the rapman machine is actually, looks like this one here, it's a real one in the flesh, but it actually starts out in a cardboard box. It took me 3 days to build that one. That was last summer holidays, so it is possible. The record is at about 14 hours, done by a group of university students in Germany last Christmas. So it is a an engineering project in its own right. So it has to be remembered that the end using of the machine isn't the only part of this sort of technology. And if I sort of introduce the BFB3000, which is a really catchy name, that's like this machine here. It's sort of like a pre-built version available to schools. And if I say that that is less than £2,000, if the materials to run at £45 a kilo, so a kilo's worth of made objects for students are less than £45. If you compare that to the next sort of further up the scale, you're talking £80,000 and nearly £800 a kilo. It's just not approachable. You cannot get there in schools. So, a quick look at some of the objects, and I'll rattle through these because some of those objects on the screen are actually out here for you to handle and have a look at a bit later on. But it's not just design and technology and things. Okay, so I've got up there some examples of mechanical parts. Some of them designed by students, some of them are parts of replacements for other machines and other projects and things. Literally mechanical parts. That's the engineer in me. These are examples from student projects that I've designed and put up on the internet, on a wiki, which we'll talk about later, based around the theme of clip it or keep it safe. And so students have designed containers or clippy things. The favourite amongst the students is this one up at the top left, which is made using a bit out of a clothes peg. It's to design hair, ornaments and things, and you can see where the amusement comes from. So, moving on from there. This is a cross-curricular project I sort of came up with, and it's actually printing a 3D terrain, it's Mount St. Helens in Washington State in America, I think. And it's downloaded from satellite data, converted into 3D objects, printed out, and I did a project with another local secondary school, looking at how this fitted into the geography curriculum and things. So a lot more than just design technology. Really interesting sort of project, never tackled before. Architects are becoming very interested in this technology. So are students. The one on the right is a freely downloadable design to make a kit so you can make your own cathedral. The one on the left is a 6-year-old's project. I think sort of mum and dad gave a little bit of help, but it was, you know that project, all go home and make a sort of toilet roll castle or whatever. This student went home and printed in 3D the sort of Greek temple. So, yes, it was designed in Google SketchUp. Those of you familiar with that know how easy it is to do. Products, prototypes, this sort of thing. Thing I really love, this one down at the bottom left-hand side, that's the first ever rapid prototype produced, 3D printed project done by any student anywhere in the world. And what is really proud is that's it. Now, it only looks like a lump of plastic at the moment, but that was groundbreaking. Done in this school. And so other products, other prototypes, that sort of thing. What's wrong with producing things like mathematical models? Those based on ellipses that are then spiralled around each other, that sort of thing. And sort of artistic and sculptural forms, and some of you might recognise Walt Disney out there. This is a project, if you like, a real student in your hand project to design iPhone stands. Again, I've produced all the teaching and learning resources which are freely available on a wiki. This I did last summer with Year 9 students. Again, immediately captured them. And the sort of iPhone stand ranging from an incredibly simple but extremely well designed product where they can sit down, prop up their iPhone and watch video whilst in bed or whatever they do with it. So that's again an example of that, and quite a lot of variety and different ways of working within that. This one I'm really proud of. One of my current Year 11 students really got captured by this technology. That is the first ever GCSE project produced anywhere in the world of where the component parts are made by 3D printing. It's, as you can see, it's a way of converting a an iPhone into a sat-nav. It clips onto the front of the bike using a downloadable app. And so you can see, there it is again, minus the strappy-on bits to attach it to the bike. So it's capturing students' imagination. It's enabling them to realise in 3D what they were only imagining not so very long ago. So a little bit about the education side of it, if you like. Somebody mentioned before, I think it was in the last bit, about iterative processes, and that's one of the things that this has opened up. In design and technology, making things always takes a long time. It means that it's expensive in time and effort, materials, that sort of thing. If we are producing a product which, for example, that just happens to be a famous musician, if that one costs 40p, we can throw it away and make a new one if it, move on to the next generation if we need to sort of redesign it. So iterative designing, rapid prototyping, cutting edge, looking at what industry is doing for real. In terms of resources and support and things, 2 years ago there was nothing available. This is now available on the internet for people to download. It's stuff that I've put together for free. Just as a list, as I said, I'm going to rattle through these bits. List of the subject areas covered. Free resources. Okay, now there is no reason with machines that cost as little as that and resources like that why students cannot be engaged in using this sort of technology. If anybody is interested, yes, I am geeky enough to have my own blog about 3D printing. Not many people can actually claim that. I have my blog. It's education based. It's not just about the technology of 3D printing. Please have a visit. It's updated since then. Don't just take my word for it. This technology, this machine, at BET, not this January just gone, the one before, it was selected as being best digital device for schools. So, as it says there, fascinating example of design in its own right, and please do come and have a look a little bit later on. So, there it is there. As I said, don't just take my word for it. It looks a little bit staged. Yes, in some ways it is, but that is the fascination that students have. That's the fascination of how they get captured. And I could start saying words like awe and wonder and all that sort of thing. I won't, I'll leave it there. Thank you.